So you're probably thinking, wow, this is so cool. Yeah, but we kind of have to be careful. As in statistics, a lot of times it looks great and you think you can do it, but you can't. So we got to test to see if that correlation coefficient is significant. So by doing this, what we're trying to say is, all right, that correlation coefficient can tell me if I can make this line a best fit. Because it tells me, is it the data strong enough? And if I can, if it's robust enough to make these kind of decisions. All right, so let's talk about some stuff. So again, I'm taking that sample data to make the correlation coefficient. But if I had the entire data for a population, say you had the population for, you were looking at an elementary school and you wanted to know about that one elementary school and you had data on every child, then you could do the population correlation coefficient. But because we only have sample data, we can't do that. So kind of like what we did when we did one mean t-test and everything, we're going to compare our sample to the population. So if you see down here that P, we're going to use the P, but it's really called a rho because it's a Greek letter. So, and then the R again is the Pearson correlation coefficient. All right. The rho, we don't know, but the R we do. So we're going to do a hypothesis test. So, but before you get upset and like, oh, I hate these things, which I understand, they really do serve a purpose. So for the null, we're going to say rho equals 0. Now remember with the correlation coefficient, I said if it's 0, that means there's no relationship. But if there is a relationship, whether it's negative or positive, the alternative says that rho doesn't equal 0. So now, if your test concludes that the correlation coefficient is significantly different from 0, you can say it's significant. And here's the conclusion. There's significant evidence to conclude that there's a significant linear relationship between x and y because the correlation coefficient is significantly different from 0. What does that mean? It means there's a relationship between the two and it's significant, so I can use predictions to make models. All right, but what happens when there's no difference from 0? So when there's no different from 0 and it's not significant, you got to say there's insufficient evidence to conclude that there is a significant linear relationship between x and y. So what's that mean? You cannot use that regression line and you can't predict anything. So remember, if R is significant and the scatter plot shows a linear trend, the line could be used to predict the value of y based on x. If R is not significant, or if the scatter plot doesn't show a linear trend, you can't use the line. And if R is significant and if the scatter plot shows a linear trend, the line might not be appropriate or reliable for predictions outside that range of data. And you always have to be careful of that. If you have a set of data, you can't predict outside of that set of data. Okay? So again, performing the hypothesis test, we went through this. Remember, your null is that the population correlation coefficient is 0. The alternative is that it's not 0. And again, we just went over that in different colors, okay?